As you guys know, if you've been watching my videos, I build a lot of tooling for myself, and a lot of it is copied from other websites or YouTube videos or what have you. It's tooling for myself, and I enjoy building it, and hopefully you get to use the product also that I build. Well, this little drawing here and I'll show you some photos there. It was brought to my attention from a viewer. His name is Cosimo Murata. I should be able to pronounce it correctly there. And I think he's located in Italy. Should check that. But he sent me a link to a site that I think is in Russia, and said, hey, take a look at this. What do you think about building something like this? And so I went to that YouTube video, and as you can see, I guess that's Russian, but I stopped and took photographs of the build that this fellow was doing. And as you can see, this part rotates so that when you put something in the vise, it squares up in the vise. And the back is actually got a radius on it there. So with the photos, I basically did my own CAD drawing of it, trying to determine sizes, and I think I got it somewhat nailed, based on what I saw in the photos there. So I'm going to go ahead and try to build the part. I've done a blow up of it, and then also did a little step-by-step for myself, so that I try not to have Mr. Bozo come and help me along. So dug in the scrap pile, found a piece of shaft, and from this edge right here to the red line, I can get a 3-inch bar out of that. Going to shoot it down to 800 thousandths. It's quite larger than 800 right now. It's about 1.25 inches maybe. So knock that down in the lathe, and then if you remember when I built the fingers for my finger brake, I had this piece of steel, and so this has been squared up on 2 sides and 1 face. So I'll end up going ahead and cutting. It's 1.25 inches thick. So that'll give me my 1.25 inches. I need 1.5 inches by 3 inches. So I'll cut that out of the block, square it up, and get ready to go. So we'll good scrap bin product again, and looking forward for a nice fun build on this. So I'm gonna bring you on some of the steps. I'm not the guy to teach you machining, so I show little things, little bit of it. If I find there's some interest, and we will see. I'm looking for maybe a thou clearance between the actual rod and the block itself for its freedom to rotate. Again, that's a guess on my part too. All right, well, we'll move along with this project and see how it goes. Well, just squared up the block in the mill here. This was a saw edge from the last time I used the block, so just gave it a little trim, and go ahead and now cut off a 1.25 inch slice. Do that over in the bandsaw. So here's just a little quick layout, 3 inches by my 1.25 inches on the surface plate. Real simple to do it with the height gauge. Now over to the saw. Okay, here's a little chop action in the bandsaw. Working fine. It's about 2/3 of the way through the block. Well, I don't know how good that focus is, but just for shits and giggles, let's see what the saw did in a 5-inch cut. So we're on 0 there. Roughly 28 thousandths in 5 inches out of parallel. I'll take that. Okay, here we are just sizing the block, get my final sizes. got a fan there in the background, blow the smoke away. Okay, pull it out and check dimension. Be back. Well, just because I can, I'm playing with my new Hoke gauge blocks. Set it 1/250, got it on 0, and there's my part on 0. So that worked out well, and we'll continue moving on, just playing in the shop. And I don't know if you can see the finish that left, but it left a nice crosshatch. So looks like my mill head's trammed in real sweet right now. Happy about that. All right, continue on. Okay, the block, I decided to drill this 800 thousandths hole in the mill. I was debating whether to put it in the forge jaw on the lathe or do it in the mill, but I'll go ahead and punch a hole here and then finish it with a boring head to get it to 800 thousandths. I have it on the left side of my vise because the two edges are picked up on the DRO, so I don't really have to do any measuring, although I've already did lay out the hole. And then since I have it on the far side of the vise, I put together a set of spacers, 1.5 inches, that'll come over here. So when I tighten the vise down, it'll tighten square. I don't have to worry about the vise going out of square. So I'm lined up on the side here, and I'll get it set up and start drilling. Well, I got a center drill in it, and I decided to use taper shank drills that I have. So we'll start off with a 1/4 inch hole and then move on up from there. Okay, the 1/4 inch hole is punched all the way through, so we'll step it up to a larger drill bit. Probably go in a couple steps here. Okay, got a 5/8 hole punch through it. We'll clean up and then we'll go to the next side. Okay, got a 25-30 seconds in there, which is 0.781, and then I'll finish the rest boring it out. Okay, got the boring process. Well, I was shooting for 800, and I'll take that. Not bad for a blind guy. Blind in one eye and can't see out of the other. I think I hit it by luck. Well, I'm back here. So I said I hit my hole at 800 even, and I'd be lying if I told you that. I thought I hit it perfect, but I've been checking, and I got these piece of crap aftermarket Chinese, Taiwanese, I don't know. It could be me. So I've tried using two different, what are these called? Snap gauges. Two different inside gauges. I've had my micrometer going at it. I've had my other micrometer going at it. Trying to figure out what did I hit on a hole center so that I could hit this right. So I ended up finally, and I don't know if you'll see it or not, but I went ahead and turned apart and started at 800 thousandths and went up 1,000 steps so that I could create my own pin gauge to find out what the hell damn diameter did I hit. I didn't hit 800. Okay, I'll give you that. So what I've got is a bore of 805, and I'll make my part at 804. No reason to go back and pick up the 5,000s to hit my 800. But thought I'd just tell you. I didn't think I hit 800, but like I said, if I did hit it, I was damn lucky. Anywho, so I don't have pin gauges. I got pin gauges up to 625 and on my list to go to 1 inch, but not right now. So we'll go ahead and make the next part. Well, here's the tooling that Randy Richard built for me. I'm doing about 60,000 depth of cut on an unknown material. It is magnetic, but it's an interrupted cut. And this tool just cuts like a son of a gun. Great roughing cut. Thank you, Randy. I wish you could smell the smoke. Just got to show you. 80,000 depth of cut, interrupted, just cutting like a son of a gun. Now it's 100,000 depth of cut, interrupted because there's a keyway shaft in there. Randy, your tool is just killing it. Well, handheld here. Let me shut the lathe off. I don't know if the camera's going to stay in focus, but man, that's a beautiful thing. Look at them chips. That is just pure beauty. Okay, well, you can see there's the interrupted cut it was hitting on, but even after it passed the interrupted cut, it was still breaking the chips. Alright, got a little bit more to go. Okay, didn't show you the finish up on the rod, but there's the rod piece, and fits nice in there, nice and tight, and slides well. So I think it'll work. Good. Next thing is to rough off this front piece now and get it so it opens up. Okay, I got the part laid out, and we're going to go ahead and section this end off in the bandsaw. You can see the amount that I got to cut off, and then we'll clean it up in the mill to get it parallel. I think that's going to work out just fine. Clean it up in the mill, the rod stays in there, and the rod moves freely. Little burrs there, but get all that cleaned up. Alright, back over to the mill. Just thought I'd show you, there's my buddy. Oh, he's listening to me, taking a little snooze. Oh, I woke him up. He's being a good boy sitting out there waiting for me. Okay, well, I got the part down to size, and now it just needs some detail and cleanup, and then go ahead and finish the rod and chamfer edges to get it nice and soft. I think I might get a quick visit at the surface grinder just to enhance the surfaces. Well, took it over to the surface grinder, and that looks much better than the milled edge. And I did the back side, so guess I'm going to have to do the other edges also. It's going to look pretty. Let's get in there. Well, working on cutting the flat now. About a 40 thousandths depth of cut here. Well, there's the flat. Kind of looks like the picture. Actually, I thought about it. I went and ground the back of this, but it's got to have a little bit of a radius on it, so I got to go back and do that. Do something there. But real close, and getting close to testing this part out, see how it works. Well, the part is ready for one item, and that is to put some sort of radius angle on the back of here. But other than that, it's just about ready to get tested. See how it holds in the mill. Happy so far at how the finishes turned out on it, and we'll bring you back when I figure out what I'm going to do here on the back and how. Well, since everything else has got a ground surface, I had to finish the rod also here. Okay, I'm liking it. Well, can't tell if that's in focus, but basically it's running flat right there, and I've got about thou and a half to 2 thou, about thou and a half, 2 thou across the whole run of the tool. I'm happy with that. It is for a rough hold in the vise, but interesting. I was eating dinner and I realized something's missing on this tool. Thought I had it all done, cleaned it all up, and I forgot something. And you can see there's supposed to be chamfers, large 1/4 inch chamfers on the top and bottom of the part, right here and right down here. So I guess I'm not done. Got to go back to work at it. And so let me get back to where I was. So I was just getting, I had scribed a line here. I think you can see it on the back of the part, center. And I was going to put it in the surface grinder, and was going to shim it and create basically a small wedge. And interesting enough, it was sitting in the surface grinder ready to go, and my phone rang, and who is it but my good friend and mentor, Chuy. He's a retired tool maker after 40 years. Just a great source of knowledge, and I'm very fortunate that he's my buddy, and he does come over and work in my shop with me. And I mentioned what I was going to do, and he just read me the riot act. Don't you dare do that. Don't you touch it. It's perfect. There's no reason to put it any kind of chamfer on the back of that, or radius on the back of that. He says anything like that, he goes, one, the vise is going to do. The vise is actually going to take up some of that. And we had a little discussion on that, and I'm going to go over to the vise and show you findings from our discussion. So let me cut now, and we'll go over to the vise. Just a quick discussion real quick. If you guys don't have a set of spacer blocks like this, they're inexpensive, they're pretty much right on, and they are so useful when you need to build something to act as a support, where you don't want to use gauge blocks in the construction area. Gauge blocks are for measuring. These are for use in the vise and stuff. So anyway, look them up. Spacer blocks are real inexpensive. They go together with set screws. Okay? Okay, we're over at the Kurt vise, and these are 1-inch spacers. There's 2 of them here, and I've gone ahead and mic'd them. I mic'd them with a Starrett mic, and that's not the number, but I just want, that's Starrett mic that reads to the whatever, way beyond a tenth. And these guys are within a couple tenths of each other, of 1 inch. So interesting enough, if you put this guy right in the center of the vise, and you tighten down, okay, I got nice grip on it, it's tightened down, and you bring the other guy over here, it basically won't go. It's tight, but it won't go. And bring it over here, and basically it's very tight, just about at it. Okay, and fooling around a couple times, sometimes you can get it to drop in there, but no. Okay, now if we take this same 1-inch gauge, move it off center just a little bit, and tighten the vise, come over here, it'll go. Come over here, and it won't go. Won't go. So what's happened there? The vise, the back jaw of the vise has canted with the part. Same thing if I move the part over here. It won't go. Over here. Well, not going to go there. Not going to go there, and it'll go there. Yeah, because that's the side, and actually it's fairly loose. So, is it a thou? Maybe it's a thou at most. But what Chewy explained to me was the back jaw of this vise is going to move. It's the front jaw that's stationary. But the back jaw is going to compensate, so there's no need to radius the back of that part. I'm the junior, right? I agree with him. I have to agree with him, right? I think he's somewhat correct. He's probably pretty correct. Well, and then of course, we also know that you can always put in when a part is off in the back, you can use a round rod in the back jaw to push. And that's basically what the radius idea in this part was supposed to do, was to compensate in that fashion while the tool is compensating in the other direction. So we're going to do some tests on that, and before we move on, I'm going to show a couple little test things here. And then also, subsequent to all this, after the whole discussion with Chewy, my other good friend, Carl, who we've done videos over his shop with the, what have we done? We did the measures, whatever the heck the damn thing's called. I'll write it on the screen. We've done that. We did the Gortons over at his shop. We've done a few things. Very, very intelligent fella, and I kiddingly call him Mr. Wizard. Well, I went over there and we were chatting about it and looking at the build, and he came up with I thought was a heck of an idea, and we'll get to that in a little bit. But to create the chamfer, the other thing that came up in comments from a lot of the viewers that looked at it was to put a set screw in this unit, or even Keld over in where are you at, Keld, Sweden, somewhere up there in the northern European countries. He even did a nice couple of sketches where he showed a set screw that would hold as a shouldered screw on both sides. Well, I got some thoughts on that too, and so we'll get to that. And then whether the bevels here are bevels or chamfers are really necessary. We'll get into that as we do the tests. Okay, so let me do some setup, and we'll get back to that. Okay, so let's start with a little test. So here's a block of aluminum. You can see it's rough sawn on the back side, rough sawn on the bottom. It's got a pretty good face right there. So we'll put that face against the fixed jaw, and we've got a parallel there. And let's start off with just go ahead and setting it in there. Put it in center, and go ahead and let the fixed jaw, the rear floating jaw, do its work. A little bit of tightening on the vise, a couple taps, parallels firm, and what do we have? Well, I think you can see. Can you see that there? The feeler gauge will go in there behind the part. On this side, it won't go in behind the part. So if reference of how this thing's twisted, we're not flat against that face. All right, so let's pull that back. Now let's try the old rod. Put that in there. Give it a tighten. It's about the same amount of degree. Couple taps. Parallels. Oh, parallel's not tight. We'll give it another one. Parallel's not tight. All right, let's try it again. See what's going on there. Set that back in there. Piece of aluminum rod right there. Give it a little tightness. Couple taps. That sounds like it's down on the parallel. Okay, same thing. What do we have this time with the feeler gauge? Feeler gauge won't go. Feeler gauge won't go. So we're showing there is that the rear jaw, even though it does have some movement, is not compensating with the back of this part being rough sawn to put it tight against the front jaw. So now let's try the tool. So we'll pull that out. Back this guy up. Put my tool I built in here. Put the part back in. Crank it up a little bit. So even adjust it so that the wheel there's got to turn. Okay. And give it a nice little tight, same thing. Couple tap taps. Sounds like it's set well. Nope. Okay, there it's tight. And what do we got? Interesting. Feeler gauge goes in, feeler gauge doesn't. So it mimicked the back of the jaw. So this does need to have some sort of bevel radius in it to compensate. That's what it certainly appears to be needing. So let's let's try something else here. So let's back this up. Put a dowel right here. Whoop. Put a dowel right there. So it stands up. Okay. Same tighten. Couple taps. Sounds good. Parallels tight. And what do we got? Huh. Feeler gauge won't go. Feeler gauge won't go. And you can actually see the, I don't know if you can see it or not, but the, let's see if we can get a quick, 223. .262. So you can see there the part needs to roll to bring that straight. So to use this tool in a fashion where it's going to work in two directions, it does need the radius along the back. So let's work on that. But let me bring you right back in a second. Okay, I'm going to explain why Chewy said don't radius the back of that tool. And so here's a larger piece of aluminum. You can see it's basically got good 90-degree corners, and then it's got a rough sawn face here. You can see what I'd sawed it off for something. Okay, and let's put it in the vise. And of course, if we just tighten down on the vise is hitting here. And you can see there's no space here. Okay, so the back jaw is not going to take up for that. Let's see if we give it a little tightness, talk it down, parallels tight. We're good on the face. We're not good on the face over here. Okay, I'm not tight over there. So the vise is basically pushed against here, and the vise is canted just a little bit, so I can actually get the feeler gauge in the back side there. And we're talking about, is this feeler gauge marked? It is, I can't read, 8 thousandths. Okay, so here's why Chewy was barking at me saying don't radius the part. I don't know that well, let's try it. Just for shits and giggles, let's try it. Okay, let's try the tool in here. Let's try the tool in here. Am I going to do this? I can do it like this. Put that parallel there, put that there, and where'd my dowel go? There's my dowel. So we know if we don't radius it, it won't work. Let's try it with the dowel behind it to create the radius. Okay, it's up against the part. Another tap tap. Parallel's nice and tight. Nice and tight. Nice and tight. So there the part has rolled it up against the jaw, and the dowel has created the radius to push the part tight. So it works pretty good. But here, okay, I've been trying to get at something. Here's why Chewy's telling me I don't need to do that. And the reason is because some time ago I purchased a couple of things from him, and this is the item that I purchased from him. This large ball bearing, which he ground a flat on the back of it. So that guy sits in there against the jaw. Tighten it down. This parallel's too high. Tighten that puppy down. Give it a couple of taps. Parallel's tight, and it's not going to go. The feeler gauge won't fit. So he's going, there's really no reason. You have another tool that will do what you want to do for the radius. So just leave your tool for when the part's straight and you have a difference in the other direction. So that's where I was getting my mentor on my Heine. He made this one, and I had purchased that one, and I'd also purchased this from him, a smaller version. This guy is 562, roughly, somewhere around there. So, but we're going to progress on. And with that said, since I can, and I have the tool to do it, I'm going to make another chewy ball for myself. And this one is it's in a 15/16 collet, so smaller than the large ball. Where'd my calipers go? The large ball that I showed you was 1.5 inches. So I'll have something at about 1 inch and then something just over a 1/2 inch. So we'll be over the surface grinder later, and we're going to make ourselves a chewy ball. All right, we'll be back with more discussion now on this tool. Now what I didn't address, and I didn't want to move the camera, but so far in my testing, the two bevels don't come into play, well, especially if I'm using that dowel back there. It's really a moot point. And by leaving those chamfers or those bevels off, I end up with more strength for the unit itself. But I got an idea. I don't have an idea. Carl had an idea. My good buddy Carl. So we'll be back. Okay, here we are making a chewy ball. Bring you back when we get down to an area of flatness that we want there. Okay, well, there's the finished product. Let's see if I can get it out of the collet right there in front of us. No, it's going to drop down in. Well, let me grab a magnet. Okay, let's see if we can get it out of that collet. Tight fit. There we go. Hey, that looks familiar, huh? That's from my buddy Brad, Tactical Keychains. So there it is. Got a nice ground ball. And you know something? I think this is going to be called a screwball. Screwy balls. Screwy ball. And I think I'm going to put these on eBay for sale. Screwy balls for sale. Alright, let's get back to the project. More on my sale literature later. Well, hope that's in focus. And anyway, here's the modification that Carl and I talked about, was to go ahead and actually insert the dowel in the back of the tool. So you can see I had a waste piece there in the vise that allowed me to drill the hole. Now, unfortunately, you didn't see any work on this. The card was full and I didn't catch it, so we have none of the work that I did there. But anyway, you can see the waste piece there, and I opted not to go all the way through the part, and I did that for a couple of reasons. One of the reasons was that way you don't have to chase it falling through. I don't have to pin it to stay in place. There was discussion from some of the viewers, quite a few, that thought about pinning this piece, and I was really leaning forward to doing that. And at least for me, I'm not going to do it. I'm going to leave it loose, and I think it's a little more user-friendly because I can actually pull it out very quickly and use this as a parallel, or leave the radius in there. I was thinking of burying it, something down behind there. So anyway, I was looking at using another method where I had a knob on here, but that really just could end up hitting on the vise. So I'm happy with this setup, and let's go try it as a test in the vise. Okay, this is the original block we had earlier. There's about 70 thousandths of difference in the length of this block, in the thickness, and about 10 thousandths on the face about a square. The back is square. So we'll crank it in there and grab our little tapper. Parallel's nice and tight, and the parts in there really nice and clean. Works well, and you can see here the variance. I hope you can see that, but the variance that's on the back of the block there. And let's see with the feeler gauge real quick. There's 75 thousandths right there. So 75 on that side, and can't fit 75 thousandths there. So it adjusts real nice, and I'm happy with the pin, the way I set it up. I know everybody's going to have a different opinion on it, on how to do it. And then just for the fun of it, this is the other block that you can see the taper there on the face, and you can see the roughness and the offset of that face there also. But again, whoop. Parallel is nice and tight, parts nice and tight. So real happy with the build. I think it's going to be useful, and it'll get limited use in the shop, of course, but I think it's going to be really great. I think on bigger parts, rougher parts, the chewy ball may work good. The thing about using the ball is you can see even on steel, it'll dimple because of the pressure of the point there. But if this is one of your final passes and you allow for it, it wouldn't be a problem. So hope you guys enjoyed the build and a little bit of testing, and we'll catch you soon.